Hello friends, welcome back to Beyond Pipelines. This is a special moment for me because this is going to be my anniversary lecture of this channel, Beyond Pipelines. And I've got a very unique topic which is really beyond the day-to-day pipeline design life of the pipeliners. Recently I came across one query from my friend asking about what will be the impact of blasting near the live pipeline and what measures should be taken, on what basis the blasting can be accepted at certain distance from the live pipeline. And then I realized that only few requirements are known to us, to me rather, but the details are not known. So then I decided that I must do some research on this topic and make a nice lecture on it so that people will be more aware of what are the precautions to be taken and how the decision can be taken safely. Hence this lecture. So friends, we are going to talk about blasting around live oil and gas pipelines. And it is also associated with the buildings and structures around the blasting site. So let's begin. Why this lecture? So as I just mentioned to you, in pipeline oil and gas industry, we often encounter situations where blasting techniques must be used near live pipelines and buildings and structures. Okay, these pipelines typically transport large volume of hydrocarbons, which is very critical inventory, making the integrity of the pipelines absolutely critical. So how can we ensure that their safety is maintained while blasting occurs in the close proximity? This lecture will explore exactly that. So let's see what is blasting and its effect on pipelines and buildings. Blasting is typically employed for constructing the roads or tunnels through mountains, or excavating the trenches for buried pipelines, or leveling large areas for housing developments. The vibrations generated during blasting can impact adjacent pipelines, potentially causing the cracks in the pipe or damaging the external coating. If the pipelines are made of GRE, which is glass reinforced epoxy, which is a bit more sensitive material to the vibrations, then it can compromise the integrity of such pipelines. The vibrations from the blasting. The vibrations induced by blasting can lead to significant economic consequences if they cause damage to the critical pipelines, like state-owned oil and gas transportation lines, cross-country lines, as well as the culturally significant structures like monuments or regional buildings, or some very critical operational buildings. Not just pipelines, but the houses and buildings also must be protected from the effect of vibrations caused by blasting. As I said, the community living in the houses. When blasting occurs near buildings or operational oil and gas pipelines, only minimum amount of explosives is used. Blasting is carried out with the highest level of precaution, and the blast direction is carefully planned. This process or methodology is also called controlled blasting. Maintaining a recommended safe distance is crucial to prevent vibrations from impacting the nearby structures and pipelines. In the next slide, we will see the significance of frequency of vibration induced during blasting with natural frequency of the building or pipelines to be protected. Execution frequencies of blasting as compared to earthquake. Any structure, building or pipeline has a natural frequency, as you are all aware, which is typically quite low, lower than 4 Hz. Structural damage occurs when the frequency of external vibrations matches the natural frequency of the structure, leading to resonance. Okay. So that means the induced frequency resonates with the natural frequency, and then it creates a detrimental effect. During an earthquake, for example, the vibration frequency is generally low, less than 6 hertz, due to longer duration, 5 to 6 seconds of the earthquake that normally happens, and greater distance of the earthquake source from the buildings on the surface of the earth. So even though magnitude of the earthquake is high, because of the longer distance, the frequency is normally low, below 6 hertz. And the low frequency of earthquakes therefore makes it more likely to resonate with the natural frequency of the buildings and structures or pipelines, and thereby increasing the risk of the damage. In contrast, blasting vibrations, the vibrations induced during blasting, are short in duration, hardly 1 or 2 seconds, because it is normally a controlled blasting, and originate from a much closer distance. Therefore, their frequency is typically much higher, above 25 hertz, than the natural frequency of the pipelines and structure, making them less vulnerable. So the frequency measurement, or the assessment becomes important, and normally the frequency of the vibrations induced by blasting are of higher levels, and therefore the resonance with natural frequency can be easily avoided. Let's see how this is analyzed and assessed during the actual blasting. So there is a term called peak particle velocity. Peak particle velocity is a key parameter used to measure the intensity of ground vibrations caused by the blasting. It refers to the maximum velocity at which a particle in the ground moves due to seismic waves generated by an explosion. PPV is typically measured in millimeters per second. So you can imagine its magnitude is so small, and is an important factor in assessing the potential impact of blasting on nearby structures, pipelines, and the environment. Empirical equation for calculation of PPV is given below. Okay, and it's basically proportional to the distance of the blasting site from the structure, building, or pipeline which is point of our interest, and the maximum charge per delay, and some constants which are related to the soil properties of the site. Measurement of these vibrations or PPV due to blasting near the pipeline is crucial, as I mentioned before, to assess the potential damage risk involved. A triaxial geophone based seismograph is the primary instrument used to measure ground vibrations caused by the blasting. For buried pipelines, the geophone is placed, or sensors in simple words, is placed on the soil surface directly on top of the pipeline, or at certain distance inside the trench, at certain distance from the buried live pipeline. For above ground structures, the sensors are placed at the foundation or the most vulnerable part of that building or structure. During blasting, the seismograph, the sensors will record time history data of the vibrations, and PPV is extracted from the highest velocity recorded in any direction in millimeters per second. Now, what are the limiting values of PPV? To what extent these kind of PPV or vibrations can be accepted? So let us see. PPV limits are typically determined by the ownership and type of property or pipeline that could be getting affected. In simple terms, if the blasting is conducted by the property or pipeline owner himself, then he may assume a relatively higher risk higher level of risk as compared to the situation where third party property is getting affected, which is obvious. Anybody will think about that logical aspect. Additionally, it's important to consider that higher risk should not be taken when the affected property or pipeline is critical or sensitive. For example, state owned oil and gas pipeline, transportation pipeline, which carries the major amount of inventory, like cross country gas network or the oil export pipelines, or the in terms of buildings and structures, if you want to take, then culturally significant structures like monuments or religious buildings, that requires more stringent risk management. So we can't ignore the risk part due to blasting near such critical pipelines or buildings, because they are very important. Considering these factors, the permissible PPV values vary, and some universally accepted limits are summarized in the next slide. So this table gives the limiting PPV values based on the dominant execution frequencies. As I mentioned in the earlier part of the lecture, the frequency of the vibration, the induced frequency of the vibration is very important, because that should not resonate with the natural frequency, and therefore the PPV limits are higher when the frequency is higher, the induced frequency is higher. Normally, as I mentioned, the frequencies of the vibrations induced from the blasting will be in the range of 20 onwards or 25 hertz and beyond or higher, and therefore the the acceptable limits with respect to that frequency of PPV I have highlighted with yellow in these cells. So I will just tell you the three types are there. One is pipelines or building not belonging to the owner. So you are doing the blasting where the third party is running their pipelines or the buildings are there, and domestic houses or interfield pipelines are there. In that case, the PPV limits are specified here in this table. Industrial buildings and frame structure, which are better designed, having stronger design, will allow slightly higher velocities. And as I mentioned before, if the owner himself, the owner of the buildings or pipelines, is developing some area nearby, which is his own area, then he can take slightly higher risk, and therefore the section B of this table shows that pipelines or buildings belonging to the owner, and then you can see the PPV acceptable values are slightly higher. Okay. And then the third category is very critical, which is cross-country pipelines, which are state-owned gas or oil export lines, historical buildings, or religious properties. In such cases, the acceptable limits of PPV are very limited. So that is with 25 hertz frequency or higher, it's 10 millimeters per second. As we have seen before, the frequency of the wave during blasting is normally higher than 25 hertz. However, it is always estimated at each project site. It's better to estimate it to ensure that it is going to be higher. Typical requirements specified in oil and gas industry. So based on this theoretical part that we saw, the concept behind the frequency of the vibration induced by the blasting and the natural frequency and its resonance, on that basis, and the ownership of the property, on those two bases, we have seen that the PPV acceptable values of PPV are specified as a universal standard practice. Now you will understand that in most of the oil and gas standards, when they say that the PPV value for the cross country pipeline is acceptable limit is 10 millimeters per second, and the minimum safe distance should be 50 meters from the blasting site. So now you will realize that from where these values are derived. This is the importance of this lecture. Now, if you have to make it more safe, or if the frequency is going to be slightly lower, or PPV is higher, then what you can do is increase the distance or reduce the blasting charge. By doing that, you can control the PPV and frequency. For less critical pipelines or flow lines or buildings, the acceptable PPV value can be slightly higher as specified in the table, which ranges from 15 millimeters per second to 25 millimeters per second, depending upon property ownership. The blast location distance can be increased, the charge can be reduced based on the project specific conditions and soil properties. So I believe with these requirements, you will now realize that the basis for such requirements outlined in the standards in most of the oil and gas companies. I believe now you are in a better shape for accepting the your pipelines near the blasting sites. What should be the distance, and on what basis you can control it, what measures are taken and why they are taken, and you will be able to review the method statements or the calculations submitted by the blasting engineers to you for the approval. So I hope this will help you in taking the right decisions at right point of time. Thank you and see you again. Bye bye.